right, since I know everyone here is paying attention, is ready to do some math, so let's go. So class.
Yes.
Ooh, excellent. All right, so let's go through finding velocity. Velocity, v of a falling rock, previous example, t equals 1 second after it begins to fall. So let's go back to the previous problem, and let's see, here we go. All right, previous problem. We had an equation right here. So it was falling at that many feet per second over the whole thing. So it is s, which is my position of my function, f of t, which is, that's the function notation. So that's position, and it means the same thing. 16t squared gives the distance s, and falls right here, approximate. It takes 890 feet to fall into the river. So we are now trying to find yeah. So we have the function here, which is that what it was? All right, yeah. All right, find the velocity after 1 second. So now there is a couple different ways of doing this, and the one I prefer is like this. So take the limit as h approaches 0. I get f of x plus h, f of x or h. Now, do you guys recall why I prefer this one? It's going to give me something. It's going to slope. It's the derivative. There we go. It's the derivative. So it's going to give me the equation of the slope. So I can find at any given point. The reason why I want to do that, do I have to do this? Do I have to do it more than once? Yes. And it's eventually asking for any time. And so that's what it's going to be asking for anyway. So if you have the equation, it's easier to plug it in over and over again to find out what the slope is at any given point. So, and since this is actually falling, that is a rate of change. Rate of change is going to be like distance over time. So that's what it's referring to as like the rate that it's falling, so your velocity. All right, so let's go ahead. If I'm plugging it in, this is going to be 16x plus h squared minus 16x all over h. Oh, that's x squared. And I'm going to expand that right there. So I get 16 quantity x squared plus 2xh plus h squared minus 16x squared. All this is going to be over h. So if I expand it, distribute here, so I get 16x squared plus 32xh plus 16h squared minus 16x squared. There's all my over h, my limit as h approaches 0. And the whole purpose of doing this is going to be this part right here. What's going to happen to my 16x squareds? It's going to cancel out, so that goes away. That goes away. And what's my favorite thing to do? Say F that, right? So I'm going to factor it out. H, I'm left with quantity 32x plus 16h all over h. Hello.
Hi.
Yeah.
I organized your desk a little.
Thank you, I appreciate it. You know what, that is probably one of the better things that actually happened yesterday. So, yes. Huh? It was actually pretty good. So, but coming in and finding my desk clean, like this morning I like almost couldn't make it to work because I was getting flooded out. I had flash floods where I live. And so both my roads leaving my house, I have 2 washes I have to go through. And so, but my truck still made it. But yeah. Anyway, but yesterday was good. But coming into a clean desk, I was super happy. It's like one of those weird things. It's like coming home and find out you have clean sheets, your mom made your bed, yes. And it's still warm from out of the dryer, so you like just like sometimes you just want to lay on that pile of warm clothes and just like curl up, especially on a cold day. Anyway, so what do we get here? What's going to happen to my h's? Cancel out. And I'm going to be left with what? 32x. Now, what does that actually mean? So I'm going to bring that over to the next page here. So that means f prime of t, because my function was in t, right? 32t. And that's the equation of the slope at any given time, right? Yes? Yes, no, maybe? Okay. Now, it's asking us for that first one, what was my velocity? And if you guys remember, if I take the derivative, so if I start with f of x, that's my position, f prime of x is velocity, and f double prime of x is acceleration. I put it on the board after the video the other day, so I just wanted to so sometimes you just see it as F, V, or A. So after 1 second, so it's going to ask for F prime of 1 is going to be 32. Now my velocity, you have to label your units. What is the velocity units? Is it meters? It's a feet or meters? Okay, yeah, it's feet per second. Nope, this is so we're not talking about acceleration. So, all right, next one. It was asking for 7.4. And go ahead, plug that in a calculator because I'm not that good at math. plug it in the calculator. Alright, go ahead, Blade, say it.
236.8 feet per second.
So what was the 7.4 in yesterday's problem? What was the 7.4 from yesterday's problem? No, that's acceleration.
Oh,
Yeah, per second squared is acceleration. The ending point, like when it hits the water, right? So that's the velocity that it's traveling at when it hits the water. Make sense? Now, that's a big difference in between what we had of this thing right here, right? Isn't that a big difference there? Why is it different than that? It's the same function. But why is it different? Didn't we found it here? What's the difference here? Okay, so right here, this is asking for the average velocity. So over the entire 7.4 seconds, that's the average velocity for the whole thing. So we yes, at the very end it was going really fast, but at the very beginning it's going very slow, right? So that's what it's trying to show. So there's a difference in between the average velocity, which is just average amount. So starts off slow, ends up fast, where we were able to find how fast it was going at the very last, as it was hitting.
That's like instantaneous velocity?
Yes, that is right at that point. And my last part of this says at any given time, but I started with that one because it made the math a whole lot easier. All right, so basically right here, slope of a tangent line, rate of change is a function, velocity are all found using the same limit. So they like using that. I don't really care for that one right there. Like I said, the doing x plus h, I don't know why. Just my mind doesn't really like that for some reason. But it does work. Find the derivative. Okay, this one right here is going to be like the one while we're doing. So we're using this. So we're going to find f prime of c. So we're finding f prime of c using the limit as x approaches c. Limit as x approaches c. And what is my c in this case? 2. So it's going to be f of x, which is all of this, 2x squared minus 3x minus 2 minus f of 2. F of 2. So that's going to give me, I plug all this in. So that's going to give me, let me see, 2 squared is 4, times 2 is 8, minus 2 times 3 is, and minus 2. What's that going to give me? 0. Over x minus 0, right? So I wrote it down there so we could see what the x minus c is. Oh, it's not x minus 0, it's x minus 2. I'm sorry. There we go. I'm like, wait a minute. Something doesn't seem right.
I thought C testing isn't C like the one, the variable inside, not the.
Mm-hmm. Yeah.
So would be zero as well? For underside?
No. This right here? No. We gotta factor it. So we can take the limit. So if we try to do this right here, what's gonna happen here? We get 0 in denominator, but I can't have 0 in denominator, right? So the way that we're doing this is we're plugging it in, and we're gonna find a hole. So where we plug it in at, we're gonna find a hole. But what do we do when we have holes? There's something that we do with the
Factor the top.
yeah, factor the top and cancel out the bottom, right? So that's where that's going to come into play. So now this is going to turn into 2x squared minus 3x minus 2 over x minus 2. Now, see, this is the method I like using. A times C. What two numbers? So we got A, B, C, so that's going to give me a negative 4. And I get two numbers, add together to be my B value, which is negative 3. So I get negative 4 and positive 1. Alright, so from there I can go 2x squared minus 4x plus 1x minus 2 over x minus 2. Factor by grouping. What can I take out of that first group? I can take a 2x, right? And I'm left with x minus 2. And this next one, 1. Positive 1. There's always one thing you have to take out when you factor by grouping. So it could be just 1 if that's what I already have. So positive 1. And I'm left with x minus 2. Now regroup. I get 2x plus 1, x minus 2, x minus 2. So the whole purpose of doing this is to get rid of my hole. So I make a hole. That's why I want this one right here to give me this, and I'm going to have to solve for it. So my x minus 2's go away. I'm left with an equation right here where I have now the limit as x approaches 2. Now can I plug that in? So I plug that in. I can plug in 2 because the bottom's canceled out. So it's 2 times 2 is 4 plus 1 is 5. So that gives me, in words, the slope when x is 2 of my function f is 5. Yeah.
How did you get 4x?
Right here? Okay, so that came up right here. I don't know, like, I know Hagen is pretty good at going over this a lot, but I don't know what ways he does this anymore. So we got A times C. Are you okay with A times C? Okay, so this here, A, B, C. So we could actually, this is my format. So I multiply them two together, I get negative 4, right? Now, factors of negative 4. I would get, to get that one, I'd get like a negative 1 times 4, or negative 4 times 1, negative 2 times 2, right? To get the negative 4. Now, of those combinations there, it has to give me this letter right here, this, my b value. It has to give me my b. In this case, my b is -3. So when I add the two together, they have to give me b. And that was my -4 and +1. So I separate my terms. So if I combine these two together again, my -4x and my +1x, I get my -3x. Does that make sense? So yeah. So again, if you never seen this before, yeah, that's what I'm doing. If you guys use like a different method or something else is easier, so feel free. I like this way because you could actually list it out. So especially on those problems that are kind of difficult, it's like you got to brute force it sometimes. If you can't think of the number right away, you got to brute force it. Other questions? Concerns, complaints, conspiracy theories.
Are aliens real?
Yes, they are.
Have you seen one?
Yeah, Home Depot parking lot. Wow, that was bad, right? So, anyway, let's see. I know this is actually kind of a problem. All right. So far, we have given 3 interpretations of the derivative: geometric, the derivative slope of the tangent line to the graph at any given point, rate of change, function interpretation of f of the derivative f prime c, a change at that point, and physical interpretation when distance s of the time t of objects is rectilinear motion is given by the function s equals f of t. The derivative f prime of t sub naught, which is my initial time, is the, or whatever given time they give me, is the velocity of the object at time t. So this term you're going to see a lot. Rectilinear motion refers to moving left and right. So if I have a negative velocity, it's usually going to be left. And if I have a positive velocity, it's going to be going right. That's the best way to try to describe it. And how many more of these do we got? Okay. Now, find the derivative f at x equals 8. Use the derivative f prime of 8. Find the equation of the tangent line to this. All right, so yeah, this one's kind of a pain, but life goes on. So it's going to be the whole thing. Let's see. Let's do f prime of 8 is equal to the limit as x approaches 8 of 2x minus, that's going to be 16, square root of 16 is 4, over x minus 8. Now, this is one of those weird problems where you have to look at it and be like, oh, hey, crap, I really can't do anything with this. So, anyone want to come up with a way to try and get rid of that radical? And it was a special word for it. Yeah.
I don't know the word, but you're supposed to multiply the numerator, right?
Okay. By?
By both.
Plus 4. Very good. Remember, you're always multiplying by the value of 1.
Is it the conjugate? Is that what
Yes, conjugate. Very good. Yes, conjugate. That's the word of the day. Conjugate. Good job. Give yourself a high five. Okay. Oh, okay. Yeah. See, there we go. Alright, so we're multiplying by the conjugate right there in the numerator. What's going to happen in the numerator when I do my, it's going to 2x, and so it's going to be minus 16 over x minus 8 times quantity to x plus 4. Like that. And what can I do with that numerator there? Factor, what am I factoring out? Yeah, 2 quantity x minus 4 over, no, it's 8, sorry. X minus 8. That's the reason why I didn't try and distribute, because I'm going to cancel that thing out anyway. And 2x plus 4 and now I could take the limit as x approaches 8. So I'm going to end up with, on top I get 2, and on bottom, as I plug that in, so that's going to be 4 plus 4 now, which is, 4 plus 4 is 8. So 1 over 4. Now, what did that mean? Meaning of what we just did. This right here is the derivative, which is also known as the slope of the tangent. Very good. Slope of the tangent. There's a reason why I keep saying this over and over again, because it's going to ask you, do this, and do this. So to get the equation of the tangent, I have to have the slope, and I also have to have a point. So I need one point and the slope. So, do I have a point? I have a point. And do I have a slope? Yes, I do. So I'm going to use what form? Point slope. Very good. That's the reason why I keep saying it over and over again, to try and get that in your head. So it's going to be point slope for this. So I get y minus y1, which is 4, equals m times quantity x minus x1, which is 8. What's up, my dude? Thank you. Alright, so we get y minus 4, 1 over 4, x minus 2, add 4 to both sides, y equals 1 over 4 x and plus 2. Now, this is the equation of the tangent line. My pen's sticky. There's a little felt thing on here that's supposed to, but it's all used up. Anyway, does that make sense? Questions? So far, no?
It's really easy. You just gotta remember the equations.
Yeah, and it's over and over again. We keep doing the same thing over and over again. So slope, tangent line, slope, tangent line, slope, tangent line. It has to do with everything. Everything is the slope of the line. All right. Table below shows several values. Y equals fx, that is continuous out of the interval right here. Approximate the derivative at 2. So can we approximate this? Since we don't have an equation, can I try and find what it actually would be? Okay. So how do you think I could approximate this? Yeah, just find the slope, right? So this is referred, again, what type of line would it be called? A line in between 2 points is your secant line. So we're doing the slope at the secant line. So my secant line in this case is going to be y2, which is, if you notice, I'm doing both sides of 2. Because I'm approximating, because that's right in between there, right? So that's how I'm going to approximate that. So I'm going to do 33 minus 3 over 3 minus 1. So I get 30 over 2, 15. Now, using information to make sure this is correct. Intermediate value theorem. Does this make sense? Okay. So intermediate value theorem says that if I find out that the chicken crossed the road has to be between there, right? The start and finish. So is 15 between 3 and 33? Yes, it is. There we go. Is that a lot easier now? Okay. All right, I think that's the last slide, right? Yeah. All right, so make sure you guys all like, share, and subscribe. Let me see if today, no, what do we got, like 15 minutes left? You can use that. Homework, bless you, Tuesday? Does that sound good? Do Tuesday? Yeah. All right.
It's just 2.1, right?
Yeah, just 2.1.